All right, you guys, this is one of my favorite lessons that I get to teach all year because it's like basically algebra on steroids. So if you like algebra, you're going to love this. If you don't like algebra, I apologize in advance. So what we're going to be doing today is we're going to do what we call trig proofs, but I want to put your mind at ease a little bit. This is nothing like a proof that you would have done in geometry. This is more like using algebra to help you change something into something else. Okay, so a lot like stuff we did in 5.1, we're just going to beef it up a little bit. Okay, so what I did first is I made a set of guidelines to kind of help you problem solve. So if you're working on a problem and you get stuck, maybe look through these guidelines to try to give you an idea of what to do next or what you can do next, okay? But essentially, here's what you're going to be dealing with. You are dealing with trying to make, okay, here's your goal. You're trying to make the left side of the equation equal the right side of the equation, okay? Or just make both sides equal to each other. So the question is this stuff over here, is this equal to 2? Okay, now what I'm doing right now for you, this is not a trig proof. This is just an algebraic thing, just to kind of help warm you up for, what we're going to be doing next. So I am not going to do anything with this 2. I am just going to try to make all of this stuff somehow equal to. Okay, and you're just using algebra to do that. So what I would suggest is for this particular question, I think I would start by factoring both of these things up here because they're both factorable to x plus 1 times x minus 1. And I guess I'm choosing to approach it this way because I'd rather not find a common denominator. So I'm factoring the top. And then I'm just going to reevaluate. Remember, I'm trying to prove that this is equal to 2, so I can't actually do anything with the 2. It just kind of comes with the work. All right, what do I see that I could do? Well, actually, look, x plus 1, nope, wrong one. I have an x minus 1 and an x minus 1. Those cancel, and then these x plus 1s cancel each other out. All right, let's reevaluate. What do I have left? I have an x plus 1 minus x minus 1. I'm hoping it equals 2. I'm going to distribute probably. This is going to be negative x plus 1. And then look what happens. Negative x plus x cancels, and you get 2 is equal to 2. You have just proved this statement. We're going to be very fancy, okay? We're going to do something super fancy. So there's this mathematical statement that we use when you make a proof, okay? It's QED. It's an abbreviation for Quod Erat Demonstratum. I can never pronounce it right. It's right here. It's Latin for which was to be demonstrated. Basically like, look at me, I did it. All of this stuff shows that this thing is true. All right, here's what an actual example is going to look like. My goal in this video is to go through like 5 examples for you, and then I will upload the PDF to show you the additional examples that I won't get to, and then you'll just kind of get started from there. So I'm going to choose a side of the equation to work with, and I'm going to try to choose the side that is the messiest. Okay, so I'm trying to prove that this left side is equal to the right side. So I'm going to start on the left because I feel like there's more that I can do over here. From that point, I'm just kind of using my algebra skills and all those identities that we established in 5.1 to just see what I can come up with. So in my head, I'm thinking 1 over cos. That's the same as secant, but in this case, it would be secant squared. Okay, and then what can I do with this? What can I do with this? Well, that kind of resembles a Pythagorean identity, let me write down from the 5.1 notes what the Pythagorean identity says. Okay, not exactly the same. 1 plus tangent squared equals secant squared. But remember, we can rearrange and move things around. So I could put the 1 on the other side by subtracting it over. And if I do that, that means secant squared minus 1, which is what we have, is the same as tangent squared. So I can use a Pythagorean identity to change all of this into tangent squared of beta, and that means that my proof is now done, because the goal was to make the left side equal the right side, and we have done it. So we're going to put QED, look at me. All right, here's another one. So I'm going to try to make the left side equal the right side. You could maybe try to make the right side equal the left side if you're feeling ambitious. It is possible. Okay, so what can I do? Let's see, what can I do? I think maybe I'm going to write these as like sine over cos plus cos over sine, because that would be cotangent, right? Oh, geez. It's supposed to be sine. Okay. What next? Oh man, this is going to be annoying, but I think I'm going to have to get a common denominator. So to do this common denominator step, I'm going to have to multiply both fractions by the opposite denominator. So the first fraction has to be multiplied by sine and the second one by cosine. Okay, so that's, let's just clean it up. Sine times sine, so this is going to be sine squared x over sine times cosine. And then over here I would have cos squared x over sine times cosine. Okay, now that I have a common denominator, I can add the numerators together and call it sine squared x plus cosine squared x all over sine x cos x. I know the worst part about doing these problems is bringing this thing back down every time. That's so annoying. Anyway, what can I do now? Actually, do you see all this stuff on the top here? Isn't there a Pythagorean identity that says sine squared plus cosine squared is equal to 1? So what I can do is I can change all the sine squared plus cosine squared. I can take it out and put a 1 in its place. Okay. Actually, you guys, I think we're almost done. There's one more thing we can do. Let me zoom in here. There's one more thing we can do. We can decompose this fraction. So what we can do is we can call it 1 over sine times 1 over cosine. That's the same thing as 1 over sine cos. And if we do that, we could say 1 over sine is the same as cosecant, and 1 over cosine is the same as secant, and we are done. I know they're not in the same order, but it's multiplication, so the order doesn't matter. We are done. QED. All right, let me pick 1 or 2 more to show you. Do I want to do this one? Yeah, I'll do this one. So prove the identity. Again, you can choose which side you want to work on. I think I'm going to work on this left side here. So probably what I'm going to do first is rewrite secant as 1 over cosine. Okay, the reason I wanted to do that first was because these cosines can cancel. I'm getting ahead of myself here. Okay, the cosines can cancel, and then I end up with sine squared theta equals 1 minus cosine squared theta. Okay, now what? Well, sine squared, I could write it as 1 over cosecant. That's not going to help me make it look like this. Or I could try a Pythagorean identity. So you could go to your Pythagorean identities, pull the only one that has sine squared in it, and think about rearranging terms. So what is sine squared equal to in this identity? Well, if I wanted to get sine squared alone, I would have to subtract the cosine squared. So sine squared is equal to 1 minus cosine squared. So I could take sine squared and write it as 1 minus cosine squared, and that means that we are finished with this proof. We have made the left side equal the right side. All right, let's do one more, shall we? I'll find a good one for you so that you have a nice example to help you with your homework. This is a perfect one right here. Okay. I think for this question, I'm going to start on the left side again, although both sides of this equation are quite messy, and you probably could work on both sides or either side and come to some sort of conclusion. Now, here's the catch, okay? On the left side, I cannot decompose this fraction because I don't have a single term on the bottom. I also am kind of stuck because I can't really write sine or cosine a different way. I also don't have any squared terms, so that means Pythagorean identities are off the table. So here's what you do in this situation. When you're kind of stuck or limited and you have a fraction, one thing you can do is you can multiply the top and the bottom of the fraction by the conjugate. The conjugate is the exact same thing that you have in your denominator, but you change the sign in the middle. This is just a way to kind of rewrite it a different way and maybe give you more options. So I'm going to multiply by the conjugate on the top and the bottom. Okay, so on the bottom, I would end up with 1 minus sine squared of t, because the middle terms would end up canceling there. Okay, so it just gives me more things that I can work with. I think I'm going to go back to the denominator now and try to figure out, if I can do something with the squared term. So this is where anytime you see a squared, usually we want to try to get the Pythagorean identities involved. So I'm going to go back to this one, and I'm going to say, is there a way I could rewrite it and make it look like this? Well, if I move the sign to the other side, you would have to subtract it to move it over. Now we're talking, because 1 minus sine squared is the same as this stuff here, right? So I can put cosine squared in its place. Okay? Here's the thing. I'm doing all this stuff, and I don't actually know if it's going to work. Okay? I might try something, and algebraically it actually, is correct, but it may not get me to my end result. My end result being that I want it to look like the right-hand side. Okay? So what could happen, and I just want to be, upfront and warn you of this, what could happen is you could try something, and it doesn't work, and then you have to go back to the drawing board. Okay, you have to go back to the beginning and try something else. So that could happen to me at any point in time. If it does, oh well, I'll just go back and try something different. So far, everything is starting to kind of look similar. If you look at the top now has a plus sign, and that's what we want. The bottom has a cosine, that's what we want. We just need to kind of simplify. So if I go back to this numerator and I factor out a cosine of t, If I factor out a cosine of t, it's going to look like this. And then what I should be able to do that will get me to a solution is I should be able to cancel a single cosine from the top with one cosine from the bottom. And that would leave me with 1 plus sine t over cosine of t. And that is exactly what we were looking for. So we are finished with this problem. Okay, so your homework assignment is a worksheet with a lot of things that look very similar to this. It's going to be kind of a trial and error thing for you at first. So I want you to try it. If you get stuck, you need to let me know, and I will, I'll try to help you as much as I can.